Welcome everybody. We'll gradually drift in over the next couple of minutes and then we will get started. Welcome back to the second day of our first ever MDENet Annual Symposium. I hope you all had as good a time as I did yesterday, listening to some very interesting talks, including by several of the panellists that we have here this morning. I'm starting relatively slowly in the hope that this gives us a chance to have people gradually drift in. What I can't do, in fact, is see how many people we have attending. If anybody who can give me a clue on the private chat. That's great, thank you very much. Let's give it a couple of minutes to let people come in before we actually get going, because we've not yet hit the number we mostly had yesterday, which suggests that I might not be the only person who had a little bit of trouble logging in. Ah, we've lost somebody. Your hand is up, Yangi. It's good to see you. Good. Right, well, it's 2 minutes past. Let's get going with this panel. So we've got quite a broad topic here about how we can, in general, get MDE practically adopted, so that that includes several aspects of the question, both, you know, what do we have to do based on the current state of MDE, and in what respects do we have to improve MDE and its support and its availability in order to get MDE more practically adopted, more widely adopted than it is right now. And so that's the broad topic of our panel today. So what I'm going to do in a moment is I'm going to invite each of our panelists to talk for a reasonably strict 5 minutes, which they're all prepared to do. And then we're going to turn over to questions from the audience. You are free to ask questions either of any particular panelist if something in what they say fires your interest and you'd like to follow it up, or ask a general question of interest and I will direct it to one or more or all of the panelists, and we'll see how that goes. So just to get started, I'm Perdita Stevens. I should have said perhaps at the beginning. I am a professor of mathematics and software engineering at the University of Edinburgh. With us we have, I'll give them in the order that they're going to speak in a moment. We have Tony Clark from Aston, whom some of you heard speak yesterday. We have Mohammad Mousavi from KCL, who some of you heard speak yesterday. We have Federico Tomassetti from Strumenta, whom I'm sure many of you have heard speak on other occasions. And we have Nelly Bencomo from Durham, who I think is, you're chairing a session, aren't you, later on today, Nelly?
Yes.
And I'm sure many of you know her as well. So without further ado, Tony, give us your 5 minutes on how to get MDE adopted more widely starting now. You are allowed to hesitate and repeat and deviate though if you wish.
Thank you very much, Perdita, and thank you to the organisers for inviting me. I've taken the brief to mean how do we get MDE practically applied in the wider world, and I've come up with 7 MDE maxims to live by. So I'll go through those very quickly. The first one is offer solutions, not technology. Years ago, I had an MDE-based company, which was a company that offered MDE technology as a tool. And we used to march into companies and say, we have an MDE technology solution for you. And the company director or technical director, whoever it was, said, well, what is it? What is this thing? What does it do? And we said, well, it's MDE technology. It's model driven. It's wonderful. And they would say, well, what exactly is MDE technology? What is it? Well, it's model driven. We used to say it's fantastic. It's technologically innovative. And you know, we never got very far, frankly. What we needed, and when it worked really well, was when we had either an external person or an intermediary in the company who was articulating what we were offering in terms of a solution that the company or the industry needed. And that's the first thing to say. MDE needs to offer solutions. It's not a technology in and of itself. We need to do technological innovation to offer those solutions, but we need to be aware that when we articulate it to the wider world, we articulate it in terms of solutions, and we might not even mention model-driven engineering in the way that we're discussing it with the wider world. The second maxim is have a clear understanding of system engineering pain that your stakeholders have, and the pain is not really related to innovation in any sense. The pain tends to relate to economic overruns and the costs associated with not delivering things on time or not delivering things at all, or often more importantly, the huge costs that maintenance incur after something that doesn't work properly has been delivered. And I think that those are key things that we need to understand when articulating the offer to external stakeholders. What is their pain? We must listen to them in order to understand what they need. We don't dictate the pace here. We need to understand what they want and what they need. The third one is assimilation, not a magic bullet. And the key thing for me about model-driven engineering is not a technology, it's a mindset. And if I was to boil that mindset down, I would boil it down to what I could put into code, I should put into data. And everything that we talk about in model-driven engineering, I think, flows from that basic idea. And the reason why it's so good is that if you put things into data, you can reflect on it readily, you can change it, you can transform it, you can adapt in terms of it, you can parameterize in terms of it. So that, I would say, is the way forward for large-scale adoption of model-driven engineering. It's to have that, to inculcate that idea in as many people as possible and to have them doing that. Now, they don't need model-driven technologies to do that. They can do it using programming languages. They can use it using databases. Of course, it's possibly easier if you use model-driven technologies because it knows about it and supports it. So it's to get wide-scale adoption. It's not to pretend we have a technological magic bullet. It's to have get people to have a mindset. The next one is to take note.
Let me just interrupt you and say you're on number 3 and you've had 4 3/4 minutes.
Thank you very much. I would say the next one very briefly is to take note of modern system requirements, which is to say things need to adapt and we need to get them to do that. Let's skip over one and go to modeling technologies. Traditionally don't do anything. They're static if you think about UML. And my view is modeling technologies need to be an extension of programming. And the final one, I would say, is de facto standards. We have a standard. I'm not sure it's fit for purpose. If you look at the way the programming languages have work, they work by having de facto standards, which is Darwinian selection. So I shall stop there. Thank you.
Thank you very much. People in the audience might like to note that a possible question for Tony might be, what else would you have said if the panel moderator hadn't so rudely cut you off after 5 minutes? We'll see how that goes. Thank you very much. Mohammad, over to you.
Thank you very much, Perdita, and thanks to the organizers for having me both yesterday and today. It was a joy to be at this event. So I have organized my response in under 4 items rather than 7. And these are mostly the items that I am using for my own research agenda to drive them for the future. The first one is to embrace heterogeneity in models. The second, I will first mention them, and I'll detail them as much as possible. The second one is to make use of data into building models. Third one is to support evolution, and the fourth one is to be responsible. What I mean by embracing heterogeneity is that modern systems are heterogeneous in nature. So if you look at any type of modern cyber-physical autonomous system, their design involves lots of different expertise areas, ranging from psychology all the way to physical design and mechanics of the system. And if you want to support a model-driven engineering process, you should basically speak the language of the experts of these domains. You can't force them all to speak the same language. So that's my first point. The second point is to make use of data. Models are rare. They are not often present. And we should make use of data to fill in those gaps where models are not yet there or not yet up to date. And things like model learning of different sorts could help us build models when they are not present. The third point is to support evolution. Again, models are often out of date, so they have been made in earlier stages of the design, and they've been left there while the developers moved on. So we should be able to support evolution in our models and support that throughout the development process if we want to have a usable model-driven engineering process. The fourth one, I will conclude with that, is to be responsible. We as researchers often write about responsible innovation in our grants as a paragraph that should be there. But when we are dealing with data, we see more and more often these days that ethics is playing a very, very prominent role in how we design our processes. So things like bias, fairness to different types of stakeholders, all sorts of ethical concerns that we used to read only in books are now becoming part of our processes in software engineering and model-driven engineering. And we should be aware of those and incorporate them into our research as well. That's all. Thank you.
Thank you very much. That's very admirably short. Right, Federico.
Oh, hi. Well, thank you for the invitation, first of all. And well, I will start by saying that I'm very interested into getting this problem solved and so to increase MDE adoption for basically two reasons. The first one is that I believe the MDE can actually improve the way we develop software. The second one is that I'm selling consulting, so I'm really motivated in spreading the voice about MDE. From my point of view, I think that in the MDE ecosystems, we have two different groups of people. The first one is what I call MDE experts, and those are people who write papers about MDE, create MDE frameworks, or maybe sell MDE consulting. And I think everyone here today is part of this group. And I think that to MDE experts, MDE is an end in itself. We want to study it, we want to improve it, and MDE is valuable to us. And then I think we have a second group that is the group of MDE user, let's say. So there are people that have very different problems that want to get solved, and MDE is a mean to them in the sense that it can help getting the problem solved. And I think from my point of view, the main problem we have is the communication between MDE experts and MDE users, because I think we tend to talk to MDE users in the same way that we talk among MDE experts. More practically, I would say that, well, I will reiterate the first point that Professor Clark raised, is that we should focus more on application than on the technology itself. And so I think potential users have problem like wanting to translate code from COBOL to Java, let's say, and it can be solved by implementing a transpiler that adopts some of the MDE principles. So in this sense, I think we should focus exclusively on the problem they have and in the fact that we can propose a solution, and the fact we are using MDE can be added in some footnote if we want to, but it's not really relevant. And in a way, I think of that as giving medicine to your dog. You don't need to advertise it too much. You just stick it into the food and they take it. And the second point connected to this is that I think we tend to use very abstract terms that are relevant to us because we normally want to compare very different solutions. So we need some generalization, like the concept of model, meta-model, model-to-model transformation. But I think that for people who have not seen many examples, it's very difficult to reconcile the very broad and generic idea to model to what they have. So they have difficulty to understand what a model mean in their specific case. So I think we should use more concrete terms. And that would be it for me.
Thank you. At this point, I'm regretting not having allowed Tony to run because after that, everybody is using less than 5 minutes. Never mind, we'll just have plenty of time for plenty of questions from the audience. Nelly.
Okay, thank you. The presentation I'm going to be given here, a very short presentation, is very much shaped by the fact that I am the leader of the EPSRC Project 2020 Insight. And I have got many insights from that project that it has been running 1.5 years now. We are 3 universities, UK universities there, 3 industry partners, one big one, medium one, small one. And the idea is, the main issue that we are dealing with there is the use of machine learning, AI, data science, and the risk that they pose to developing software. So I'm very biased towards that, the project, from what I am going to say here. So in model-driven engineering, we base our success on the use of abstractions. Yeah, and therefore we should be able to reuse our experience in order to apply patterns. And see here that I talk about abstractions. We don't necessarily talk about models, so it's something that is coming up here. I think personally that we have made a strong progress towards the use of MDE in industry, and one of the proofs is the fact that industry come to models conference. Yeah, and MDE, the MDE network is another good example. So there is some progress done there. It's not just all negative. However, I think that the landscape is always changing, so we need to evolve, as other panelists here have said. Then abstractions come a bit unstable. Yeah, so we need to go after those abstractions, and then it's very difficult to apply and reuse experience. So a big challenge for software engineers and software architects in industry is the fact that we need to talk with people that use machine learning, AI, data scientists, and they have their own terms. And sometimes we are speaking like in different levels or different languages. Data scientists, for example, they think very differently from us. It's another mindset. We in computer science and software engineering, and therefore model-driven engineering, we promote computing thinking. We teach our students, and we learn that is the composition, pattern recognition, pattern abstraction, and algorithm design. That is MDE for me. Yeah, we don't have to say models. Other disciplines do not necessarily offer or require that. And that is something that I always find myself with other colleagues that might be close to us, mathematicians, and they think in a different way. Their mindset is different. So we sometimes get lost in translation, at least in my case. And I am getting a bit concerned on how data scientist programs, for me, sometimes it's like going to the past. It's, in the 60s, it's a spaghetti code there. So how we are going to use abstractions and reuse experience there, that is for me a big problem. So what I see so far is that instead of computational thinking, the decomposition, pattern recognition, pattern abstraction, algorithm design, what we have is no decomposition, therefore no pattern recognition, therefore no pattern abstraction, and no algorithm good design. This is what I see from my little corner. No architectural thinking. For me, this is a must in terms of bringing model-driven engineering to industry. For me, is how we can help. So I was thinking that perhaps one of the ideas is to promote computing thinking and architectural thinking, not just in our area, but in other areas as well. So for me, it's interdisciplinary education. And that several universities, I know that they have already been working on that. I have examples. And I feel like MDE network as such is a good example of that. It's educating for that interdisciplinary work where we are able to understand ourselves together, even if we work from different corners. And I think I will stop there. Thank you.
Thank you very much. Okay, so I'm scribbling here, and I have a bunch of questions in case there are gaps, but it'd be very nice to not have to use my questions because there are so many questions from the audience. So let's see how we go. Okay. Let us start with Stefan's first question. If we can get that highlighted on the screen. Thank you very much. So the SEI recently promoted MDE in their report on the future of software engineering. Does this mean MDE is now mainstream and will be picked up by industry automatically? Cynic end. Now, who would like to tackle that question? Wave your hand or just, yeah, go ahead, Tony.
Thanks very much. I think it's an interesting to reflect how long model engineering has been around. You know, it has been around all the way back to model-driven architecture in the early 2000s, really. And there are a number of names given to model-driven engineering. So I think, you know, the cynic end point there is perhaps well made. The fact that this has been around for so long would be surprising if suddenly it was bumping into the mainstream just from this particular thing. We do see you know, colleagues in universities, I think, recognize model-driven engineering, and it's now in the curriculum up to a point. So folks are going out into the wider world with an understanding of models, and certain big engineering industries are definitely using models and model-driven engineering. But I'd be quite cynical as well about whether it's actually in the mainstream and picked up by industry automatically. Again, I go back to my point that I think it's a mindset rather than it's something that solution providers should be using as part of their tool set, and not necessarily solution consumers asking for it to be used.
Mohammad, do you have something to add?
Yeah, so I just wanted to add a slightly different perspective. I think all engineering disciplines are model-based in one way or the other. They work with their own models. That was the second point, or the first point I was making, right? If you look at mechanical engineering, even if you look at more social science type of fields like economics and psychology, they use some sort of model to reason about the systems they are studying, right? And I think the future will be in connecting these models and then making the entire engineering process model driven based on the models that we have in these different disciplines. It's a non-trivial task. So when you talk to a mechanical engineer, they use a complete different sort of models than what you're used to. But building these bridges, I think, would be one of our future challenges.
Mm-hmm. Yes, I mean, it's just to throw in my own perspective for a moment. I think one might perhaps say, what do we mean by model driven? Well, all we mean is don't get yourself bogged down in details that aren't important to the abstraction you're trying to use at that moment. And once you say it that way, it it just seems like, well, why would you do anything but be model driven? It's just a question of identifying the right models, perhaps. Tony, you want to jump in again?
Yeah, I'd be interested to know whether folks on the panel think that there's initiatives at the moment, low code and no code, for example. Is that model driven or not? Because if it is, then there is quite a large movement using this kind of approach. It's quite in the air at the moment and has been for a little while. In which case, model-driven engineering is out there.
Low code and no code and the relationship of that to MDE. We could have had an entire panel about that, and maybe we will another time. Yes, would anybody like to say something about that quickly just now?
Well, I would agree that low code and no code are form of model driven. In my opinion, they are forms that are dedicated to occasional users, so they are different from forms that you want to use as a professional performing the same task every day. So,
thank you. Let's move on. Let's move on to Stephen Powley's question that begins, good to hear panelists focusing. Can we have that up? Good to hear panelists focusing on understanding needs and pains first. Systems engineering considers people first, then process, then tools and technology. Is part of getting MDE adopted being careful not to assume that MDE is even part of the solution? That raises some interesting questions about the roles of MDE experts, perhaps, because why would you get an MDE expert involved if you thought MDE was not going to be part of the solution? So maybe that's raising interesting questions about the different roles and personas that people might adopt in dealing with this. Federico, would you like to say something about that?
Well, yes, as you were already saying, I think there is a bias. Of course, if you go to someone selling you MD consulting and ask him if it's a good idea to get MD, or someone maybe is doing a survey on MD and would really like the results, stressing how much MD is useful, there is a bias there. But I can maybe look at the first part of what Stephen was saying, and saying that I agree that there are some aspects that have a strong impact on MD being successful or not in an organization. So one may want to consider the ability of the organization to change and adapt, and so considering the people and their incentives into moving to MD. So I think one could notice these things and then conclude that maybe MD is not a good solution because there are not the right conditions.
Mm-hmm. Okay. Anybody else like to add something? Let's hear from you, Nelly, because we've not heard much from you yet.
Thank you. So what I think one of the things here that we have been talking about, I saw it like in 2 or 3 panelists, is the fact that we don't have to talk about MD to really do an MD. For me, it's abstraction. So and I think we need to be always be part of this of the solution. If no, I don't see it what other way. So I just want to remind you of this paper by Robert Franz, who passed several years ago, and Romp. I recall that one of the conclusions in that paper that was about the future of software engineering and model-driven engineering 14 years ago is the fact that perhaps models as such is not going to be explicitly named, but is going to be an implicit part of that. So sometimes the discussions is more about the terminology, and I feel like it shouldn't be the case. We would be just losing time there.
Okay, thank you very much. In fact, at this point, I'm going to use moderator's privilege and move on to a question that I had in mind to ask Mohammad, because I think it fits in quite nicely here. Your third idea there was that we should support evolution. But you didn't, within your few minutes, have time to say very much about what you thought the implications of the need to support evolution are for what we actually do. And maybe that relates to Nelly's point and to thinking about MDE as part of the solution. Would you like to say a bit more about that?
Sure. So what I meant by evolution, maybe I should first define that, and I'm sure other people will have other perspectives on that. So I think the world evolves, first of all. So we are going to deploy our software on some platform, and those platforms change all the time. So the next time we are going to run our software, it will be on a different type of hardware, different type of physical, mechanical device. So we should be able to adapt and learn about those changes and reflect them in our entire process to reproduce. Also, the software itself changes due to new requirements, all sorts of things, bug fixes, retraining of data and everything. And that means that we should have a constant process where hopefully somewhat automatically the models adapt to all these changes. So they learn about those changes that are happening in the platform, in the environment, in the requirements, and also in the software itself. And the models are updated to reflect those changes. And all the analysis and the derivations that we have done, transformations that we have done in the model-driven engineering are kind of focused on those changes. That's the main challenge, because you can't afford redoing everything from scratch, right? You should focus on those changes and focus your effort on those parts that have changed.
That's interesting. So you really are talking about the models themselves evolving more than you're talking about the idea that models should be at the level of abstraction such that the things that change are underneath the level of the model. I think one could perhaps look at it either way.
I'm not sure if I understood your latter point, but I guess other panelists could also comment.
Yeah. Anybody want to follow up on that? Nelly?
It's going to be short, Tony. I really agree with what Mohammad has said, and I think models at runtime is a clear example of that. I recall the first time when I went to models as a PhD student, I thought, this is my community, I will stay here. And I remember they didn't want me to stay there because I was not talking about UML. I was not talking about development software models. I was talking about models, abstractions that happen to be at runtime. And it could be extended to more things in these kind of evolution ideas that you are talking, Mohammad. And the fact that we can talk about models with other disciplines, as you said before, I think this is key for our success for application.
Mm-hmm.
Thank you.
Interesting. Tony?
Thank you very much. I think the point that Mohammad's raised here is absolutely essential to modern system development. If you look at the way that systems are deployed now, they're deployed into connected ecosystems that they can't possibly predict the behavior of. Mm-hmm. So there needs to be some level of adaptation. But the flip side of this is that part of the problem of developing software is that we try and get them perfectly right first time before they're deployed. And this is where we get the huge cost overruns and leading to things getting cancelled or things getting deployed when they're not ready. So adaptation is the absolute crux of the premier problem of modern software system engineering and development. And it's actually a sweet spot for model-driven engineering, I think, because the only way to do adaptation at scale, I think, is use models, as Nelly says, at runtime in all the various forms that they can occur, because that's the only way that you can make the system not be brittle. Mm-hmm. It needs to be deployed in a way that it can look at itself. It can reason about itself. It can change its own behavior. The only way it can change its behavior dynamically is by modifying the data in terms which it runs in terms of. So this is a real sweet spot for model-driven engineering approaches, and it's a real need that can be articulated out there to the stakeholders. So I completely agree with this.
Mm. Interesting, thank you. We're having a lot of agreement at this point. It would be quite interesting to get an argument going. I wonder whether we can manage that. Let's go to Jörngi Sus's question. It seems that there is a lot of impetus given to interactive and visual tools. What about the repeatability and automation of model-driven process, CI/CD or buzz ahead DevOps? Now, who would like to have a go at this one? Nobody's keen on CI/CD or DevOps. And maybe a part of the issue here is it's not completely clear that that there's even a conflict here, is there? I mean, can we be interactive and visual in determining what our processes are, and then can we have repeatability and automation in applying them? Is that how we resolve this apparent conflict here, or are there other things to say about this?
Well, I would agree with you also. From my point of view, you use interactivity and visual tools while creating the models, and then as part of your pipeline, you process them. But I mean, I don't see the conflict.
There was a blog post I read by somebody Garcia a while ago about continuous model-driven engineering. There was something along those lines which was emphasizing the need for CI/CD processes to be model aware and to be able to incorporate models into their tasks in a better way than is currently available. I don't remember very much about what that said, but maybe that's part of what Jörngi is getting at here. Okay. Let's leave that one if people don't want to say too much about that. Let's see. Now, we've already talked a bit about low and no code platforms. Let's go to another question by Stephen Powley. In the MBSE community, we see the benefit of MBSE by stealth. My old boss once built a fake Excel overlay to present a tabular view of a model to overcome management refusal to use an MBSE tool. Do the panel have their own examples of MDE by stealth? Federico.
Yes, I had a similar experience. In that case, we didn't produce an Excel as an output, but was used as an input. So sometimes what happens is that we focus on the, let's say, the user visible part of the MDE solution to make it appear more simple. So one case is letting user provide inputs that are later processed by using Excel files. Another case is creating maybe web editors with drag and drop to replace instead textual languages running in an IDE to capture the model because they are perceived as more complex.
Thank you. Anybody else got any nice examples they would like to confess to?
Perhaps I'm not sure I can give any concrete persuasive examples, although I think that most things that I would do would be MDE based, but not necessarily disclose that. But my point of view would be that everything should be MDE by stealth. You shouldn't necessarily know that it's been used. You just get the benefits of it.
That's very interesting. Thank you. Herman Piran has found the URL of the blog post I was terribly vaguely alluding to, so that's quite impressive. Thank you very much for doing that. That is indeed the one I was talking about. Okay, now where shall we go? I had a question I wanted to ask Nelly, actually. So you talked about data science as being a particularly important area where people were perhaps not taking advantage of modern software engineering understanding in general, let alone of MDE. And other people have talked about the importance of paying attention to where the pain is. So do you have anything interesting to say about where the pain in data science is and how model-driven engineering, by stealth or otherwise, might help with that pain?
That is a hard question, because what the experience I got from the work that I have been doing with industry is the fact that I suppose that they have a very abstract view of what is an architecture of the machine or machines where the software runs. So one of the problems that where I have been stuck in conversations like this is that they say, okay, this is what we think the model does. I want you to do this and program it, and that's it. My work is done. And then we are coming back and saying, okay, look at the architecture is like this. Microservices is a very complex architecture. It's not very easy to understand. It's better that you can come and hear and see how this can be more efficient, etc. And I suppose then what is I interpret what I am saying myself, that sometimes they might not even be aware of the pain, because they are not interested, at least in the example I have been trying to work with these guys, is that they are not interested in how to make that software more efficient, more connected to the requirements of the business logic. And I think there is a pain there that they are not aware yet of. We are very aware.
That's a very interesting question. Can you be in pain and not know it yet? Maybe it's you're going to be in pain. You just haven't got there. Yeah. Anybody like to add anything to that? Mohammad, you're muted right now.
Yes, I just unmuted myself. Thank you. So I was thinking about, so Nelly mentioned data science and the issue of using data science in a model-driven engineering process. And I think one of the issues there is that finding models in data is a difficult thing, right? That's what many of the machine learning techniques also have been struggling with, that they can predict something, but they don't have a model why and how they are predicting that, right? So being able to abstract away some models and understand those models, how those data-driven processes work and incorporate them into the model-driven engineering process is something that I find very challenging and very interesting. So that also connects to the issue of interpretability of and explainability of how those data-driven techniques work.
Mm-hmm. Yeah, very good point. Tony, you're also muted right now.
Thank you. I think all data scientists should be locked in a room and forced to reuse and maintain the code that they produce. And then they would appreciate the problem.
Very good. Let's move on to Stefan's second question about usability. That seems like a good link. He writes, usability of modelling technology is a topic that's been discussed a lot in the academic community. It hasn't been mentioned by any of the panellists, well, except that implicitly it has. Is it no longer relevant? Would anybody like to say anything about usability of modelling technology? Go ahead.
Thank you. I can only report bad things, I think. But I have experience of building modeling technologies, and the modeling technology experience that I've had is that as in the case with quite a lot of software engineering tools, you try and make the tool very broad so that it supports many different use cases, and therefore it becomes very complicated and unusable very quickly. One vision that I had several years ago was to take a model-driven approach to modeling technology so that people could model the modeling tools that they wanted and generate them, and therefore they would get a better fit. But I think the usability of modeling technology is not necessarily limited to to modeling technologies. The problem is broader in terms of software engineering technologies, in the sense that the use cases that the technologies are trying to support are very broad, and therefore they become quite complicated quite quickly. So sorry, I can't give a solution to that, but I can sort of share some pain.
It's interesting, isn't it? I sometimes wonder whether we're actually kind of at a sour point with some of our modeling technology, in the sense that compared with ordinary code, which people get to, you know, edit in their favorite text editor and you can use across a variety of tools rather easily, we are very tied into the tools and we get lock into particular tools. But at the same time, the tools are, as you're suggesting, you know, not so specific that they're really ideally adapted to one particular use case, which is, so maybe there are better points at either end of the spectrum than we sometimes accidentally find ourselves at with our current tooling, and maybe that's part of where our usability pain comes from. Anybody else like to say anything to that? Mohammad?
I just wanted to emphasize the point of letting people speak their own languages. So we can't force a psychologist to speak the same language as a software engineer, and that kind of connects to this point. It's our job to kind of abstract the type of information that we need for a model-driven process from the language they speak, and that's a difficult task for us. But we shouldn't make their task more difficult because we want model-driven engineering.
It's interesting. That maybe brings me on to a question which I had for Federico in the first case. So you mentioned the problem of communication between MDE users and MDE experts as something that was a big concern to you. I wanted to ask you, what is the sweet spot for what you think MDE users ought to know? So to what extent ought we to be trying to educate MDE users, and what should we mean by educating them? What should we expect MDE users to have to know?
Well, I think that ideally we should think about specific solution that we can offer and just talk in very concrete examples to those people. For example, one application, my experience of MDE is to create transpilers that are more maintainable. And so maybe we could, I don't know, write articles about, hey, you want to write your transpiler from COBOL to Java in a more maintainable way? This is what you can do. Or, for example, I've seen successful application of model-driven engineering when creating digital therapeutics apps. So one could explain that, while I think we instead tend to talk in very general terms about, models that your domain experts can use, and people are not sure what are these mythical domain experts.
Okay. Anybody else want to say anything? I'm just looking for more questions. We've got a few minutes left. We've got time for a few more questions to come. But which questions have we not answered already? Let's see. So we've got a couple of questions which are relating to the issue of whether we call it MDE or we don't call it MDE. So, for example, Stefan is saying, but if we just talk about abstraction, how do we justify doing MDE research? What's special about MDE compared to other approaches to abstraction? What are the boundaries of MDE, and is this even a relevant question? I guess part of what we've been skating around is several people have mentioned the fact that perhaps the people to whom we're selling MDE don't necessarily need to know that MDE is what we're selling. Perhaps it's sufficient for them just to know that we can help solve their problem. But that's different from the question of whether we still think we're doing a coherent discipline with its own questions. So is there a justification for doing MDE research? And if so, what's special about it? Anybody like to say anything about that? Tony?
I do think that there is justification in doing MDE research, but I think there's a number of factors to this. One is the point that I was trying to make, which was it's a mindset. One aspect of it is it's a mindset. You can do MDE in the context of many different technologies that you might not otherwise call MDE technologies. But nevertheless, it's going to be easier if you do use a technology that's MDE based. So there's definitely a place for doing MDE, justifying doing MDE research to support people who want to do MDE as a general activity, technological activity. I think it's important to acknowledge that MDE methodologies are important, and I think that's part of MDE research that you would call MDE research. And I think that one of the reasons why we haven't perhaps been as successful as an MDE community in the wider world relates to sort of what I was saying about de facto standardization and getting things that are allowing people to talk the same language and do the same things in different places and share things and build on things that other people have done. And I think that is a justifiable thing to call MDE research. So I think there's very much a lot of things that we could justify calling MDE research. It's a broader thing. I think you could do MDE without necessarily doing it on an MDE platform, let's say.
Okay.
Yeah.
Thank you. I'm going to throw in the next question as well at this point from J. Garcia Molina, since I don't think we've heard from him, and it relates to this a little bit. So, is it necessary a new open modelling platform which replaces EMF/eCore and provides usable tools? Nelly. Yeah.
I wouldn't say replace. I would say that new platforms can come up and they complement, but I wouldn't say replace.
But then that's kind of interestingly conflicting, isn't it, with Tony's point that we need de facto standards. So, yeah. Anybody else have anything to say in this direction? Federico?
Well, I would say yes. I mean, I think like many, I've get started with using MD by using EMF, and it's been a wonderful experience, but there are many problems for which I find very difficult to use EMF, because it seems like this huge thing that you have to import in your system, and in certain contexts just doesn't work, like if you want to work with the browser. So I think we need some more lightweight alternatives. For example, I think it's very interesting a project called Modelix, which is open source and started by Itemis, and there are, I think, other initiatives to create lightweight alternatives that maybe are not as powerful as EMF, but can be embedded in other systems, and I think will also make easier to adopt some MD principle without having to buy into EMF, which is a huge, which has huge implication in my opinion.
Mm-hmm. Thank you. Right, let's go to Johan Gisus. We're just in the last few minutes now, who asks, what is the speed or cadence of MDE? We server build, test and integrate code roughly every hour. When and how frequently should you expect validation and verification that your models help fulfill the requirements? Would you like to say anything about cadence? Tony?
Yes. Well, I'd like the notion of the code that we're talking about here in terms of testing, integrating, and models in the sense of models at runtime and being exactly the same thing. So therefore, they should be tested at exactly the same schedule and frequency.
Thank you. Anybody have a different opinion? We're still remarkably short of overt disagreement. Mohammad?
Again, I would like to emphasize the point of focusing on the evolution and also focusing on the data, right? So you could learn from your data where your models fell short of satisfying your requirement, where were the most complaints, most risks for your system, and then focus on those parts for your validation and verification effort. Again, the systems are growing so large that we can't have, as also Tony pointed out, we can't have completely built systems that are correct from the beginning. So we should focus on our effort on those parts that matter most when we are doing validation verification. Mm-hmm. That holds for everything, including for models, right?
Mm-hmm. Okay. Thank you. Okay, so this is probably the last question from Antonio. What about the collaborative aspect of MDE? What is your experience and impression on this topic? So I guess we could interpret this in a number of different ways, right? Yeah. We could talk about different people cooperating on making progress with the same model, or we could talk about outstanding issues that arise when we have different experts who work on different models, each recording their own concern, and then we have to bring the information recorded in those different models together. Interpret the question how you wish. Federico.
Well, I think that the collaboration model really depends on the kind of users you have. Like if you have someone that is more technical, they will be okay with, I don't know, storing models on files and using Git and also having to merge conflicts. But I think that if we want to make MDE more accessible, we need to provide other collaboration mechanisms, like, for example, real-time collaboration. And the examples I referred to before, Modelix, has this idea of making possible to have real-time collaboration and so avoiding merging conflicts, which is very important, I think, for usability.
Mm-hmm. Thank you. Anybody like to add anything in the last 2 minutes?
I'm just wondering, comment to a question by Stefan. I'm keen to get more industry voices involved. So are we thinking of having, for example, in the next panel, bringing more industry voices? That is what you're proposing, Stefan, because I think that would be a need in a next meeting of the network. It would be discussing this more with people from industry, I think.
I would like to emphasize what Stefan Scharler says, that you know, he writes in the singular first person, but it applies to all of us in MDE. I think we are very keen to get more industry involvement in MDE and in the symposium in general. So it's, you know, we are a somewhat academic panel here, but that's not exactly choice. So yes, you know, if anybody knows of people interested in MDE in any aspect in industry who are not yet involved and would like to be, point them in the direction of MDENet. We really want them here. Okay, at this point, I'm going to wrap up and say thank you very much for what I think was an interesting panel, even if I didn't manage to get any arguments going. And thank you very much for your thoughtful contributions, and thanks very much to the audience for all the questions. And now we have a coffee break before we move on with the rest of the day. Thank you very much.
Thank you.
Thank you. Bye.
Bye.